Okie dokie, welcome back. Let's go ahead and work on example 3 here, which says find the 2 points on the line y is equal to 5 that are 6 units away from the point 3, 1. So 6 units away means that I'm going to have a distance of 6, which is why I put the distance formula here. We are actually going to use this here in a second. We want to be 6 units away from this point 3, 1. So we're going to use a distance formula, but let me draw you a picture here to kind of get a better idea of what we're actually finding. So we have a couple things we need to plot. We need to plot this line y equals 5. 6 units will come in handy here in a second, but most importantly, we want to be 6 units away from this point 3, 1. So let's go ahead and plot that point. So 1, 2, 3, 1 is right here. And there we have our point. Sorry, I'm just trying to darken it in a little. Okay, so we've got that guy on there. We need the y, and y equals 5, and if you remember, that's going to be a horizontal line going through the y-axis at 5. So let's go ahead and plot that. So 1, 2, 3, 4, 5. So here is our line that we're dealing with. Sorry, I'll try and keep it as straight as possible here. It's not easy. Hopefully yours are better. Hopefully you're using a ruler or a straight edge of some sort. And I just want to darken it in so that you can actually see. Okay, so we're not allowed off of this line. So we've got that plotted. We're not allowed off of this line. We're allowed to walk up and down here as many times as we want to. But we have to be 6 units away from this point, okay? So obviously, obviously 1, 2, 3, 4, this is only 4 units, so I can't be standing right here. So I have to be further away so that the distance from me to this point is going to be 6. Let me go ahead and get a different color here so I can show you really what I mean here. Let's use red, here we go. So I want to be 6 units away. Well, I can't be directly to it because that's 4, and we know the shortest distance from 2 places is a straight line going directly towards the object. So I'm going to go out this way because I know that's going to be a little bit longer than 4, which is where I want to be. I want to be 6. So this distance has got to be 6. Now I don't have to be on this side of the line. I could actually be all the way back here and still be, let's just say that's 6 inches. I don't know if it really is, but we're just guesstimating here. So let's say that's 6 units away. So I could be in either spot and still be 6 units away from our prime guy right down here. So I'm trying essentially to find this point right here and this point right here to be 6 units away from our main point right here. So we have our line. Let me go ahead and change back colors here. We have our line y equals 5. We're not allowed off of this line, but we have 2 points here. And these 2 points, well, we don't know the x's, but we do know, well, the y has got to be 1, 2, 3, 4, 5, because we're on the line y equals 5. That's the only thing y can be. So I'm going to go ahead and fill that in there. So this guy is x and then y of 5. Same over here. I don't know the x necessarily, but I do know 1, 2, 3, 4, 5, that my y is 5, because everything along this line has got to have a y of 5, because we count up from the x-axis, and it's 5 every single time. Okay? I don't know what the x is, because like I said, I could be right here, I could be right here, a little closer, a little closer. I don't know exactly where 6 is here. So, let me show you what we're going to do here. We're going to use this distance formula. We're going to use the point 3, 1 as one of our points here. Sorry, you can't see this very well. Darken it in. 3, 1 is one of our points. And then our other 2 points, well, these are really the same thing. So my other point here is going to be x minus 5. So I'm using these 2 points with my distance formula. So we'll call this guy x1, y1, and we'll call this guy x2, y2. Okay, so let's go ahead and set it up. So we have the square root of x1, we've already deemed as 3. So we have 3 minus our x2. X2, we don't really know. We're just going to put an x in there for now. So x, because that's what we're trying to find. And then we need our squared, and then we need plus. And here's our y's. Our y1 is 1. And then minus y2 is going to be 5. And like I said, it doesn't matter which point I use, because these are going to be the same for now until we find our x. So y2 we know is going to be 5. And then quantity squared. And then, well, we don't have an equation yet in order to solve for this x, but we do know a very crucial piece of information is that our distance has got to be 6. So that means this whole distance, whatever this x is and whatever this ends up to be, has got to equal the number 6. Okay, because we want it to be. That's what we said. So, how do we solve? Well, we have a big square root, and you might think, well, this is a bunch of stuff under here. How could this all be one square root? But it is. That's the nature of the formula. So since that's all one square root, and it is isolated on the left side, I can get rid of it by squaring. And of course, what I do on the left, I have to do on the right. So this square root and this squared cancel out. These squareds have to stay. We did not cancel those out. We just canceled out the square root. So then we have 3 minus x, quantity squared, plus 1 minus 5. We can actually simplify that and say that that's negative 4, and then squaring that. And then 6 squared, we already know, is 36. Okay, so let's continue in our solving here. We can simplify this. So negative 4 squared, we know, is 16. So let's rewrite this side. So 3 minus x, quantity squared, plus 16 is equal to 36. And you might be looking to square root this, but not quite yet, because this is not isolated. We still have this 16 we have to get rid of. So let's do that. Minus 16 on each side. And I have 3 minus x, quantity squared, equals 36 minus 16. That's easy. That's 20. And now comes the point where I can actually square root this side. And that means I have to square root over here. So there we go. This square root and this squared get canceled. I'm left with 3 minus x. And be careful, because right here comes the point where you need to identify that, hey, I took the square root of this side, and I took the square root of this side. That means that not only am I going to have the positive square root of 20, but I'm also going to have the negative square root of 20. And that's actually where our two answers come from. Okay? So we actually have plus and minus the square root of 20, and that's what gives us our 2 points up here. Okay, so we keep solving for x. We have to subtract 3 on either side, and then we have negative x equals negative 3 plus or minus the square root of 20. But we don't want negative x. We want regular x. So we say positive x equals positive 3. And then if we wanted to switch the signs here, it wouldn't really matter because we have both the positive and the negative. So I can flip this, put it negative over positive, but that really doesn't do anything. I'm going to still subtract and add the square root of 20 to figure out what my answer is. Oops, sorry. So the square root of 20. Okay. So I got to figure out what that is. Now, never mind this. This could still be written as plus over minus. All right. It doesn't matter. So we just need to do 3 plus the square root of 20 and 3 minus the square root of 20 to get both of our answers. And since I'm running out of room down there, I'm going to go ahead and put them up here. Well, we need to put them in ordered pair form anyway. So I'm going to go ahead and leave my x blank. I already know my y is 5. So there's 1 point. And then my other point, still going to have a blank x, but I still know my y is 5. I just need to figure out what this is equivalent to up here. And don't leave it in radical form because that doesn't help us plot it on a coordinate plane. So let's go ahead and use this here. We need to do 3 plus the square root of 20. Oops, not 22, sorry, of 20. And that is 7.47. So let's go ahead and write that over here. 47. So that's 1 point. And that point is going to be obviously the positive one over here because this is back in the negatives and we got a positive number over here. So then our other one is going to be 3 minus the square root of 20. Gosh darn it, I did it again. Sorry, 20. Let's see what that gets us. Oh, that's going to be negative 1.47, which is kind of what we should have expected because we had 1 and then point, well, I was a little too far here, but negative 1.5-ish is where we wanted to be for this other point here. Alrighty, so let's discuss what we actually just found. Let's get rid of that. We don't need that anymore. Okay. We found the 2 points on this line that are actually 6 units away from our target point down here. Okay? We had 7.47, so we could count over 1, 2, 3, 4, 5, 6, 7. 0.47 would be about 0.5, so I was pretty close with that one too. So there's our target point, and then of course up 1, 2, 3, 4, 5 was our y, and then our other point was negative 1.47, so about 1.5. It was a little off there, but pretty darn close if you're asking me. And this is the point, negative 1.47, and then 5. So those 2 points are exactly 6 units away from the point 3, 1. So that's, and all this mess is actually our answer. Alright, I hope you understand how to solve equations with radicals. If not, maybe watch one of the examples again because we'll be working on this worksheet in class tomorrow. Thank you and have a nice night.